Okay, so this is your quiz and test review. Okay, this is going to help you get ready for your quiz on Monday and your test on Wednesday. We're going to go through some terms and definitions. Guys, just kind of say them with me. Like I said, I'm going to move fast. Really not a whole lot of point of writing down on your whiteboards. We're working on whiteboards today, but we're capturing this on our video. Okay, so you can go on YouTube and watch the video to study for your quiz. So everybody with me, a translation is a type of transformation that slides. Very good. If you said shifts, that would be okay too. So what about reflection? Yes, a reflection flips. What about a rotation? Turns. Very good. Okay, someone raise your hand and give me the 3 degrees of rotations. The 3 degrees of rotations. Yes, Mason.
90, 180, 270.
Yes, sir. Good job. Okay, and we know that one of them, it really doesn't matter if it's clockwise or counterclockwise. Do y'all remember which one?
180.
180, right? Because it's 2 clicks either way. All right, so that one doesn't matter, but 90 and 270, you have to say clockwise or counterclockwise. All right, so after a figure is translated or transformed, really, because it's all of them, the new figure is called what? The new figure is called what? Write that one on your boards. What is the new figure called? I want everybody to kind of rack your brain just for a couple seconds. Okay, what is the new figure called? What is it, guys?
Image.
It is an image. Very good. It's an image. All right, and then the sum of the angle measures of a triangle. All the angles in a triangle add up to?
360.
Triangle. Guys, 180 degrees. 180 degrees. Remember, the sum of the angle measures of a triangle. So in chapter 3 is like all about your angles, and we're going to do all kinds of stuff with that one concept, okay? So you do need to remember that, all right? 180 degrees. Okay, so here's some more. I want you to write down on your boards what you think the answer is. When reflecting across the x-axis, you take the opposite of the?
Y value.
Yes, okay, y value. All right, answer the next question now on your boards. Answer the next question. Okay, what is it, guys? It's the x value. Remember, whatever axis you're reflecting, you take the opposite of the other value. All right, so answer the next question. You have these coordinates. Which axis was reflected? Which axis was reflected? X, Y, both, or neither? Okay. All right, don't say it out loud. Write your answers down. Nick?
X.
It is the x-axis, and the reason why is because I see opposite y values. If I see opposite y values, it means that that point crossed the x-axis to get to the new value. Okay? And because my x values are the same, I know the y-axis was not reflected. All right, so my answer here is x-axis. All right, okay, transformation, give me one. What's a real-life example of a transformation? Mason.
A caterpillar.
Caterpillar. Caterpillar into a butterfly, right? Oh my goodness. Is it C-A-T-E-R, caterpillar, or caterpillar?
Cat too.
Oh my goodness. I am drawing a total...
It's a caterpillar.
Okay, I apologize for looking ridiculous on my video because I am drawing a blank if there's an R there. We know what it means, okay? Sorry guys, not perfect here. Okay, I think it is caterpillar. No, that doesn't look right. Okay, what about a translation? We're just going to move on. We're just going to move on. I have a master's degree. I can't remember how to spell caterpillar. Okay, translation. Translation. Remember how we talked about like your bedrooms? Moving your furniture, that could be one.
Couch.
Okay, moving a couch, sliding a couch across the room. Just honestly just something that you could slide or shift to a different location, I would definitely accept. Okay, so we could just say furniture. All right. What's the next one? Reflection?
Mirror.
Selfie.
Furniture. Yes, reflection, selfie. Or no, mirror. Okay. And then a rotation. Anybody remember? It's like a real.
A wheel.
Oh, what?
Earth.
Yeah, Earth. Very good. So planet Earth rotates on an axis. Anything that rotates around a fixed point. Okay, so a wheel, Earth, even our solar system because it's orbiting. Okay, just anything like that. Was it this class we started talking about like the solar system and how like I don't remember if it was this one. You know how when you really start zooming out. Has anybody ever seen one of those videos that starts zooming out planet Earth, like in the solar system, and then you see like what a tiny insignificant speck planet Earth is? Doesn't it make you feel so small?
I never seen that. I don't know.
You've never seen it? Oh my goodness, we need to watch one of
Like
those.
go from your house to like.
We saw it last year in chapel.
Don't it go from like your house to the country?
Yes, I know. Yes. Okay. All right. So we're just going to go basic with a wheel. That could be a Ferris wheel. That could be a carousel. It could be Earth. All right. Like we said. All right. Now let's figure out what kind of transformation is happening here. We're going to go through these quickly. Is it translation, reflection, or rotation?
Rotation.
All right. I hear rotation, Mr. Nick. So, yeah. Which way? Yep.
Clockwise.
Yes, great job. Okay, because we see, guys, pick a side on the figure. Okay, so I like to pick the top side. All right, in order to turn that top side to be on its side, I need to go, and you can think of it as how many clicks. Okay, so one click is 90 degrees. One click would get it down to this side. How many clicks would get it down to the bottom? 2 clicks, so that would be 180. How many clicks would make that side over on the left side? 270, okay? So that's how we can determine, and because it goes right, we can say 90 degrees clockwise, and I'm totally fine with you just abbreviating CW. Does anybody remember what direction is equal to this in the opposite direction? What degree? 270. So I could have taken this one and gone 1, 2, 3 clicks this way, 270 counterclockwise, and it would have been the same thing. So there will be 2 acceptable answers on a problem like this. All right. Okay. What kind of transformation's happening here?
Translation.
Yes, a translation. Okay, so there's not a whole lot to write here, but again, it's being captured on the video that you need to watch over the weekend to study for your quiz. What about this one? What kind of transformation?
Reflection. No, because they're not the same size. So rotation.
Transformation. Translation.
Oh, translation.
You just said it. None.
Wait, no.
None. Why is it none?
Because it's a different size.
They're different sizes, okay? So what you learned yesterday in 2.4 is that these types of transformations don't change size. That's what makes them rigid motion transformations, okay, which we started to learn about in section 2.4. So if you see one on your quiz and your test, now this is a dilation, but we're not learning that till 2.5. This is none of the options that I have, okay? It's not any one of those 3 because it changes size. So yeah, it was a trick question, okay? All right, what about the next one? There are 2 answers, okay? There are 2 answers here,
Reflected, rotated.
It's rotated and reflected.
okay? All right, so let's go to the reflection answer. Do you guys see how the smiley face is on the same side of the line of reflection on both sides? Okay, so this is a reflection across which axis? Y'all just tell me. It's a reflection across which axis? What one's up and down? Not a trick question, guys. Which one goes up and down? Y. So it's a reflection across the y-axis. Okay? So yes, that is one answer. Someone raise your hand and tell me the other answer. Josh? Yes, very good. All right, remember 180 degrees doesn't have, because 2 clicks will get it to the same spot. So he is exactly correct. This is also a 180 degree rotation. All right, because if I go one, we'll call it again a click. One click, either way, it'll either make the smiley face upside down or right side up, correct? So then if I go one more click, then it'll get it to that direction. Now, I guess technically either way. All right, so good job. Great job on that, guys. All right, so now I want you to set up, and you're gonna need to go on the x-axis, you need to go 7 out, okay? Go ahead and set up a graph. We're about to do 2, but you can do it on the same graph, okay? We're about to do 2. All right, and you only need to go up 4. You don't need to go 5 and 6. That'll save you some time.
How many out?
To the right, you need to go 7. All right, go ahead and set up your graphs. I'll give you a minute to do that. You need to plot these points. Here we go. Plot these points with me. Point W, 1, 2. Plot that point. Point X, 1, 4. Plot that point. Point Y, 4, 4.
It's a square.
No, it's not. And Z is 4, 2.
It looks like a trapezoid. It's a rectangle.
It's a square.
It's a trapezoid.
1, 2, 1, 4,
So rectangle.
4, 2, and 4, 4. All right.
It's a rectangle.
Okay, how do I know whether or not, so let's settle this argument. How do I know whether it's a rectangle or a square, Connor?
Well, the way I know is because there's like if it were a square, there'd only be like 4 boxes inside of it, but there's 6, and they go like out. It goes out more.
Yeah, so how many units is it across?
3.
How many units is it up and down? 2.
2.
So it has to be the same units, length and width, in order to be a square. So this is a rectangle. Now that's beside the point, guys, so you are arguing about the wrong thing. Okay, now I need to follow the translation. This is my original figure. Now I need you to translate this figure 3 units right. Okay, translate the figure 3 units right. Okay, so when I move this first point 3 units right, where does it end up?
It's set up 4
It's on the 4, right? I move the 1 over 3, it's on the 4. So these 2 points, all right, when I move them, do you agree? The points on the left, I shift them 3 points to the right, and then I shift these. Okay, now they go from a 4 to a 7.
What?
All right. The right 2 points, it would have been helpful if I had labeled these, Y and Z. Points Y and Z had to shift 3 units right. I shifted each point in the rectangle 3 units right. And then remember, guys, dotted line. Dotted lines. Okay? All right, dotted lines connect. All right, that's how you do the translation. Any questions there?
No. I think
Okay. Don't rate. We're about to do another one. That's the whole reason we use the board. Okay, don't erase your whole graph. Just erase. Don't even erase the whole original rectangle because we're about to use the same exact rectangle. All right, so now you gotta plot the same exact rectangle again then. Okay, 4, 2, 4, 4. This time label your points so we can call them what they are, W, X, Y, and Z. Okay, so we have our original rectangle again. Hopefully you didn't, you still have it intact. Okay, now I want you to reflect this rectangle across the Y axis. All right, you do not have to come up with the new ordered pairs to do this. You can, but you don't have to. So I'm going to explain in a minute. All right, this was on your quiz Wednesday too. A very easy way to do that. to reflect it in the y-axis. But I want to give you just a minute to see if you can do it on your own. Guys, what y value is point W on? What y value? It's on a 2, right? So it needs to stay on the 2. Now, if I'm reflecting across y, I do the opposite of x. So what x value is W on? 1. So now, what's the opposite of 1?
-1.
-1. So that's where my new point goes, just right to the other side. So up here, for my y, I just go over to a -1 again.
I got it.
So for y and z, they are on x values of 4, so where do my new points go?
-4.
-4.
Oh, I get it.
And then all I do is connect the points.
So,
I got it.
Okay?
I knew I got it.
So on the quiz Monday, hopefully you can reflect the correct axis. And guys, look. Look what happened to the figure. It said reflected in the y-axis, and look which axis it flipped over. It flipped over the y-axis when I did the opposite x values. It flipped over the y-axis. Okay? So that's what I did with the reflection. You have rotations. I don't have enough time. We only have 4 minutes left in class. The code is everything. You will have the code on your quiz and your test. So clockwise is to flip them and do the opposite of x.
The code won't be filled in on the test?
Yes.
Oh, let's go.
Okay? The code is to flip them and do the opposite of x. Can anybody tell me what point A is going to be? What's point A going to be when I rotate it clockwise 90 degrees?
It's going to be -2, -4.
Correct. Flip them and do the opposite of y. -2, -4. So something you can do when you're watching the video, because we're running out of time, you go ahead while you're studying. Don't pack up. Okay, I'm going to get through as much of this as I can. All right? You go ahead and fill in the other ones. What about the 180-degree rotation? This is the one that you should be able actually to do without a key. Without a key. Because 180 degrees, if you remember, is what, Connor?
What?
Do you know 180?
So I have a question.
Okay, what's your question?
Don't we get out at 9:20?
No, we get out at 9:15. Okay, guys, look at this. 180 degrees, look up here, okay, is just the opposite of the x and y value. So what's the opposite of -4? +4. What's the opposite of 2?
Negative.
-2. You keep the same order, and you just do the opposite sign of whatever the original is. So do you see how that could be pretty simple? 180, I just know whatever the sign was in the original, now it's the opposite sign. And then for 90 counterclockwise, we go x, y, and then we go -y, x. So now we have to flip the y value. Can anybody tell me what my new A would be if I flipped them and did the opposite of y?
A would be
-2.
Yep, -2, -4. All right, so I have 2 slides that, actually, we still have 2 minutes. I'm going to keep going. And again, do B and C on these on your own while you're studying to help you study. I did the first one so you would have one to kind of go off of. All right? We have describing relationships. So this is on your quiz on Monday, to describe the translation of the point to its image. Okay, so how do I do that? From my x values, am I going left or right? And by how many? On a number line. For my y values, am I going up or down? And by how many? On a number line. Can anybody tell me translation? Anybody tell me translation? What would it be? Would it be right or left? And then for my y, would it be up or down? Okay. Anybody tell me? All right. Mason?
Right 4,
Yep.
up 5.
Yeah.
No,
So
down 5.
right 4 and down 5. Do you guys agree?
Yeah.
Yes, very good. -4 to 0 is right 4. 7 down to 2 is down 5. All right, so here's some redemption right here. Can anybody from the first one that we asked at the beginning of the lesson, can anybody tell me which axis is reflected here? Which axis? Yes.
X.
It is the x-axis because I have opposite y values. Way to go. Okay, so it is the x-axis.
You want us to go run some boards here?
Good job, Cameron. Okay, so again, there are still a couple more slides in this review PowerPoint that will be on the YouTube video. Okay, so make sure you take advantage of that resource to study for your quiz and your test next week over 2.1 to 2.4. So I do have to dismiss you guys, and then I'll pick back up on the video in just a minute.
What are we doing in race boards?
Okay, real quick, I need to go back and correct something. On that first rotation, I should have flipped X and Y and done the opposite of X. X was -4 in the original ordered pair, so now it's +4, right? So I got in a little bit of a hurry, and that would have messed y'all up doing B and C on your own. Okay, so 90 degrees clockwise, I flip them and do the opposite of X. All right, so now let's go back to the slide we were just working in, describing relationships. Okay, so on the third point now, describe the rotation. So the one we know it's not is which one? All right, now if you're thinking 180, you're exactly right. It can't be 180 because I reversed the order. So I know it's either 90 or 270. Now I just need to figure out the direction. I flipped them, and now my opposite values, I flipped my Y value. I flipped them and did the opposite of Y, which was 90 degrees clockwise, or 270. I'm sorry, counterclockwise. Nope, had it right the first time. 90 degrees clockwise, or 270 counterclockwise. And while I'm thinking about it, because it is easily confused, you will have this code or those what you're supposed to do, like the X, Y, and then on this one, -Y, X. You will have those codes on your quiz and test next week. All right, so now let's talk about congruent figures. This is what I'm talking about with the codes, the test key. You will have that on the quiz and test. All right, so with congruent figures, I need to figure out which figures, A, B, C, D, or E, are congruent with each other. All right, so look at these figures to yourself. Which ones do you think are congruent? All right, if you said B and D, you're right. But you can't just say B and D, you have to tell me why. So what kind of transformation is happening between the two? Okay, so I'm suspecting a reflection, right? But I need to look at a point. You see how this bottom corner, the 90-degree corner, is on -4? Well, the bottom corner over here is on +4. So this is a true reflection across which axis? Okay, if you said the y-axis, you are correct because it's clearly crossing the y-axis. All right, now the other set is C and A and Y. Why are C and A congruent? Well, one is because I can tell they're both 3 units wide and 3 units high. So I can tell by their size, counting the units, that they are congruent. Now I have to identify what kind of transformation. It is a translation. And how do I figure out how many? I have to, again, identify my corresponding points. You heard me say that yesterday. So pick your corresponding points and count. 1, 2, 3, 1, 2, 3. 3 units right, 3 units down. And that's your translation. All right, so that's congruent figures. Now, last but not least, our sequence of rigid motions. Describe the sequence of rigid motions from the solid figure to the dotted figure. All right, so again, I'm trying to figure out what kind of transformation gets me from point A to point B. Is it a rotation? Well, in this case, a rotation could not be identified, All right, because again, it's the same unit, so it would kind of look the same depending how I rotated it. Rotation won't work. A reflection won't work because my values are a little off. Okay, so my x value here is at -1, but down here it's at 0. Okay, so that's not going to work. The only one that'll work is a translation. Now I just have to pick, I'm going to say it one more time, the corresponding point. So are these 2 points corresponding? Do they correspond? No. So if I count there, I'm going to be wrong. I have to pick the same point on both figures. And now I count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So the sequence of rigid motions here would be to translate 5 units right and 7 units down. Okay, and that pretty much covers everything you need to know for sections 2.1 to 2.4.